Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today, my topic is for class 9th, and this is today we are going to start new chapter, and the chapter is chapter 5, and which is called gravitation. And today topic is law of gravitation. So, before starting our topic, which is law of gravitation, so we just say that what is the main theme, or what is the causes behind this the law of gravitation. The first man who came up with the idea of gravity was Isaac Newton. It was an evening of 1665 when he was trying to solve the mystery why planets revolve around the sun. This is the sun. So they are just sitting and solving the mystery why the planets are revolving the sun. Suddenly, an apple fell from the tree. This is I can just draw, this is the apple, and the apple is just fell from the tree under which the Isaac was sitting. So the idea of gravity flashed in his mind. He discovered not only the cause of falling that apple, but also the cause that makes the planets to revolve around the sun and the moon around the earth. So in this unit, we in detail discuss the concepts of gravitation. So on the basis of his observation, Newton's conclude that the force which causes an apple to fall on the earth, this is the earth, and the force which keeps the moon in its orbit are the same nature, both have the same nature. He further conclude that there exists a force due to which every body of the universe attracts every other body. He named this force the force of gravitation. So this is a well-known law for this force of gravitation, and also in some books they write this is the fourth law of Newton. Law of gravity is the fourth law after the three successful laws of motion. So now we are going to start about the law of gravity. I said that one object having greater mass, let's suppose this object, or this is the mass of the earth, you can say, or this is the heavy object, and one object having which is lighter mass, and this is equal to small m. So this body attracts the small object with some force, and this small object also applies some force and attract the another body. But the nature of these two forces are equal but opposite in magnitude. According to this law of universal gravitation, he said that the distance between their center, the masses of these center, they denote the separation by d. So he said that every body in the universe attracts every other body with a force which is directly proportional, which is directly proportional to the product of their masses, to the product of their masses. This is the statement for the law of gravitation. So this is, we can say this is the first. And the second, he said that this this attractive force is inversely proportional to the square of the distance between their centers, the square of the distance between their centers. So we combine equation 1 and 2, we can rewrite for this. He can say that the force of attraction is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. So if we remove this is the sign of proportionality, and if we remove this, we can use equality and use one constant, proportionality constant, and here we are using the gravitational constant, capital G. So this is the formula for the force of gravitation. So here G is the universal constant or constant of gravitation. The value of G, capital G, is equal to 6.673 into 10 raised power minus 11 Newton meter square per kg square. So students, remember this value. The examiner may ask this value in your annual exam in the form of an MCQ. So they can ask what is the value of gravitational constant G. So the value of G is 6.673 into 10 raised power minus 11, and the unit for this gravitational constant is Newton meter square per kg square. So this value you can see from here, 10 raised power minus 11. So due to this small value of G, the gravitational force of attraction between objects around us is very small, and we do not feel it. Since the mass of the earth is very large, if you can see from here, this is the mass of the earth and this is the object, or this is the small mass of the apple. So since the mass of the earth is very large, it attracts nearby objects with a significant force. This we can say that this is the weight of an object on the earth and is the result of the gravitational force of attraction between the earth and the object. So in an exam point of view, this is the derivation for the law of gravitation. This is the formula for the force of gravitation. So in paper point of view, the examiner may ask a question. They can ask in your also in your exam, or in also the question is in your exercise. The question is in the form of, they can also say that explain why is the law of gravitation important to us, or they can also say that do you attract the earth or the earth attracts you? Which one is attracting with a larger force? So by Newton's third law of motion, every action has reaction, but they have both are equal in magnitude. So we also attract earth and earth also attracts us, but due to the small mass, we applying some force on earth, but they cannot, you can say, we cannot conclude the small amount of force. So earth also attracts us. So the law of gravitation and the Newton's third law, they are mutually possible. So we can note that if the small capital M or small m both attracts towards with each other, so it with the force F, and M2 attracts or M attracts capital small m, if the force acting on this is capital M on M is considered as action, then the force on small m we can consider this is reaction force. So the action and reaction due to the force of gravitation are equal in magnitude but opposite in direction. So this is the consistent with Newton's third law of motion, which states to every action there is always an equal but opposite reaction. So we can say that both a small and a heavier or lighter object also applies some force of attraction, but due to the small value of g, we cannot feel, or the earth cannot feel like that the earth attracts towards us, but due to the capital or the larger mass of the earth, we attract towards the earth. So this is the main phenomena about law of gravitation. So there is a small topic in next page, and that is equal to gravitational field. So according to the Newton's third law, it's the new topic, a small topic, gravitational field. Newton's third law, the gravitation force between a body of mass m and the earth, we can write this gravitational force as capital G. This is the mass of the earth, and this is the mass of a small object, and we use r square, or you can also use d square. So here ma is the mass of the earth, this is the mass of the object or small body, and the spacing between their center or the distance between them is r square. So the weight of the body is due to the gravitational force which the earth attracts a body. So gravitational force is a non-contact force. For example, the velocity of a body thrown up goes on decreasing when I have a ball and I throw it. So initially I give some velocity, but this velocity is decreasing when the ball is going up. The velocity is increasing while the ball has returned to its initial value. Means when the ball is thrown up, the velocity is decreased, and when it's come back, the velocity of the ball is increasing. So this is due to the gravitational pull of the earth acting on the body, whether the body is in contact with the earth or not. So this such force, we can say that this is called the field force. Due to this field force, the velocity of the object is decreasing or increasing. So it is assumed that gravitational field exists all around the earth. We can say that this is the earth. So the gravitational field exists all around the earth. So the gravitational field becomes weaker and weaker as we go further and further away from the earth. From here, when we goes to the infinity, and when the distance is increasing, So the value of gravitational fields is weaker and weaker and weaker. So in the gravitational field of the earth, the gravitational force per unit mass, the gravitational force per unit mass is the gravitational field strength of the earth. It's mean at any place its value is equal to the value of small g at that point. So near the surface of earth, the gravitational field strength is equal to 10 Newton per kg. So we can write this in our numerical values. So this is the gravitational field strength near the surface of the earth. So students, note down this topic. This is very important topic, gravitational topic, and this chapter is very important paper point of view. So keep watching, and thank you, students.